Okay, so the third method that we're going to talk about this evening is using the solving a system by elimination method. Obviously, with everything, I like to save the best for last. Notice that these two equations are not in slope-intercept form. The form that they're in here is called general form. And general form is useful because you can actually line up your x's and your y's and what it's equal to. So what I'm going to do is, the whole idea here is to vertically combine the values next to x, y, and the equal sign. And while I'm doing that, I'm also going to try to eliminate one of the variables. It doesn't matter which one. It could be the x's or the y's. But if I'm able to eliminate one of the variables, then I can solve for x or y and find the ordered pair that is the solution. So I'm going to go ahead and combine these because they're all set up for me beautifully. If I add negative 4x and positive 4x, they cancel each other out. Positive 8y combined with a negative 2y is 6y, and negative 24 combined with a negative 12 is negative 36. If I go ahead and divide both sides by 6, y is going to be negative 6. Just like in the past, any system that has a solution, the solution comes in the form of an ordered pair. So a lot of people feel like they've done enough work at this point and they should be done, but they have not done all the work because they have to find a value for x so that they have the full solution. I can use either one of these original equations, but what I'm going to do is write it out, and wherever I see y, I'm going to plug in negative 6. I'm using the first one. So negative 4x plus 12 equals negative 12. When I multiply negative 2 and negative 6, it became positive. I'm going to subtract 12 from both sides. So I have negative 4x equals negative 24. And then divide both sides by negative 4. And so x is going to be positive 6. And I have the full solution, x and y. I'm actually now going to jump down to number 3. So I'm looking at number 3, and I'm thinking about if I were to combine these now as they are, how to handle canceling out a variable. If you notice, the y's will be able to cancel each other out, so I can go right to adding these together. If I add 2x to 1x, I get 3x. The y's cancel each other out. This is going to be equal to 30, 19 plus 11. If I divide both sides by 3, I've got my x value. If I plug this into the very first equation, I will be able to solve for y. Negative y equals 1. If I multiply or divide both sides by negative 1, I'll get y equals negative 1. Here is my ordered pair right here. Take a moment and do number 2 and number 4. And when you come back, I will review the answers to both of those problems. Okay, the answer to number 2, hopefully you got x equals 7 and y equals negative 1. If you didn't, you're going to want to pause the video and look and see where you went different than I did. And then number 4, I got x equals negative 1 and y equals negative 1. On the next page, we have really interesting examples because if you look at these, they don't have variables that are going to match up perfectly without us doing some kind of manipulating. So notice that if I combine the x's, they won't cancel out, and if I combine the y's, they won't cancel out. So what I'm going to need to do is I'm going to need to do some manipulating. And the first thing I'm going to have to do is ask myself if I want to cancel out x's or if I want to cancel out y's. Doesn't matter. So if I decide that I'm going to cancel out x's, then I have to figure out a way to make them equal to each other. And the only rule here is that whatever I do, I have to do to each piece in my equation. I'm looking at these and I'm thinking about the least common multiple of negative 4 and negative 10. And it's 40, right? 4 times 10. Actually, no, it's 20. It can be 20. 4 goes into 20. 10 goes into 20. So what I'm going to do is I'm going to change these equations and make it so that the x's are equal to those things, I'm going to put a set of parentheses around these. If I want to make this equation start with a negative 20, I have to multiply the whole thing by 5. And if I want the second equation to equal negative 20, then I have to multiply the whole thing by 2. The only thing is, if I want them to cancel out, one of them has to be positive and one has to be negative. The way that I have this set up right now, they're both going to come out negative. So I'm going to actually make my 2 a negative 2, so that when I multiply it out, it will give me a positive 20. So here I go. I'm going to rewrite all of these. The first equation rewritten is going to be negative 20x minus 10y set equal to 70. I multiply each of these pieces by 5. The second one is going to be positive 20x minus 14y equals positive 50 because I multiplied each of these pieces by negative 2. After I've done this manipulating, I can now add these together and the x's are going to cancel out. The y's become negative 24y. The end of this becomes 120. And the last step of this is to divide both sides by negative 24, giving me a y value of, that's going to give me a value of negative 5 for y. And then if I go ahead and I plug negative 5 into one of these original equations for y, I can go ahead and find the x. So I'm going to do negative 4x minus 2 times negative 5 equals 14. That was my first equation. Doesn't matter which one I use. They're both going to give me the same answer. Multiplying negative 2 times negative 5 gives me a positive 10. Subtract 10 from both sides. So I have negative 4x equals 4. Divide both sides by negative 4. X is negative 1. So that's a different kind of situation because we had work that we had to do before we even added them together to cancel out a variable. Let's go to the next one. And the next one, again, I'm asking myself what I can do to cancel out either x's or y's. This time, let's cancel out the y's. I have negative 2y and negative 5y. The least common multiple is 10. So if I'm going to change this first one and make it so that this is 10, I have to multiply the entire thing by 5. If I'm going to make this one, the second one, 10, I'm going to multiply the whole thing by 2. Since both of these are negative to begin with, one of my numbers has to be negative so that I have one positive y and one negative y. And it doesn't matter which one, so I'll just put it with the first one. If I multiply each of these pieces by negative 5 and I rewrite it, I'm going to have negative 15x plus 10y equals negative 10. The second one, I'm going to have 10x minus 10y equals 20. When I combine these, my y's cancel. My x's combined give me negative 5x. My numbers combined give me a positive 10. If I divide both sides by negative 5, x is negative 2. Feels like we should be done, but we're not because we have to find the y value that goes along with that. I'm going to use the very first equation and plug negative 2 in for x. I'm going to kind of section these ones off. That gives me negative 6 minus 2y equals 2. Add 6 to both sides. Negative 2y equals 8. If I divide both sides by negative 2, my y value is going to be negative 4. And that is the closing of section 3.11.